Good, 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 good. Good, good. Sorry. Hey, it's not infrequent that I get asked about my tactical Oakley bag here. Thing's like a decade old. Somebody just asked me a minute ago about it. And I think all of a sudden I got insecure that I was also carrying this bag, which my spouse lovingly packed some items in here. So it turns out, even though it may look pretty funky, it's actually the swag bag. So for those that have either maybe, I don't know, maybe questions that stump me, because, hey, I need to be fed as well. I need to learn too. So I don't know, there's some items, some of which are probably extraordinarily valuable. Others of which you might throw in the trash on your way out. We'll see. Some of which I actually couldn't part with. I was going to bring a Linker D baseball cap. It's just they did such a good job. It's all black. It's got the Linker D sweet, the hip logo on the front. So, but we have some other items. So anyway, thanks for coming out. It's good to see everyone. I think actually pleased that we are not overspilling for a couple of reasons. One, those that are following along as we put hands on keyboard most of the night, which, by the way, notice what I'm holding in one hand. We could be challenged this evening. We'll see. So it's nice that there's not that we're not overflowing. That hopefully, my hope is, and one of my frustrations outside of speakers who leave the font too small, my other frustration is that I can't keep up with what's happening in the labs sometimes, and that makes me feel like I'm the one of the less intelligent people in the room. Or I don't always feel good by that. It's frustrating. And so my point is, I'm hopeful that everyone will keep pace or be able to, because we'll just slow it on down. Moreover, if you can't tell by the bad jokes already, it's a pretty friendly environment. I'm here to share what I know and hopefully, honestly, learn a couple of things in the process. There's some open source software we're going to look at tonight. We're going to focus on Istio specifically. There's actually a lot of other open source software. Istio itself is comprised of a ton of other open source projects. So with that, it had, I think, I see a couple of friendly faces. I think some folks that I'd seen maybe before this meetup had dropped off for about a year. And I'm seeing some folks that we just started it back up, and seeing some folks that showed up to the last one, and some new faces. Curious, how many of you have I not spoken with before, or how many have not had the absolute pleasure of listening to me before? Okay, that's great. That's fantastic. Speaking of listening to me, did anyone see the fact that we announced a few more topics, a few more months, what talks were coming? We're going to fill those in with minimally someone else other than me, so that it isn't just monotonous having to listen to dad jokes every time you guys come. So I promise, if for nothing else, I'll call on one of you and you'll have to come up and share. Good. Anyway, it's the meetup's Cloud Native Austin. I've been one of the hats that I wear is as a Docker captain, and so I've been fortunate enough to help organize Docker Austin. We'll likely be just parlaying with that meetup and probably co-announcing and co-scheduling many of the same meetups, kind of joining those two together. So anyone coming here from having seen the announcement out of the Docker Austin meetup group? All right, very good. Okay. Anyway, so tonight's main agenda is get to fingers on keyboard as quick as we can. For those that were here last time, I did make something of a promise about less slides, less talking, more keyboards. For anyone that does want to speak, please do. Please, there are open slots. Submit some suggestions. There's a form to do so. If anyone would like to sponsor, please do. Hopefully, I'm also soliciting feedback on this evening's treats and sweet beverages. So I've already got a +1 on the Shiner, so that's that was a no-brainer, by the way, for the Shiner. So we are fairly open source friendly. This is a CNCF affiliated kind of sponsored meetup, so we're going to talk about a lot of cloud native things, and for better or worse. Since I'm somewhat headlong into service meshes in that area, there's a lot of service meshes actually. We're going to talk about probably the most popularized one this evening. That'll be something of a consistent portion of the agenda. So just fair warning, hopefully that's a good thing. These are some of our sponsors in the past and now, and your logo could be here. Okay. All right, a little bit of a see how we break the ice. We're kind of getting to know each other. Speaking of getting to know each other, anybody have anything they want to share? That could be that maybe you're hiring someone, maybe you're looking for a job, maybe you just want a public forum that's on a live streamed YouTube channel to just complain about your job. You can join me in doing that. I promise you it will happen before the evening's over. Or anybody learn anything recently? Anybody attend a conference or know of one that's coming up that people might think is interesting, worth knowing? Something that pops to mind, in part because we've got a DockerCon speaker in the audience, is that DockerCon was all but set to come back to Austin this year in June. And I almost fell back and fainted when they said that that's not happening. They just based on some changes that are happening, they pulled out of DockerCon this year. They are looking to get creative though. So we'll still have Docker birthday. I think it's the 6th birthday coming up. We'll still do some things. But yeah, no DockerCon in Austin. So okay. I kind of skipped over it. Did anyone have something to share? Please do.
Yeah, I was just going to mention that even though DockerCon won't be here, the Linux Foundation's Open Source Summit will be here June 22nd to the 24th here in Austin. The call for presenters is still open, so the lineup isn't yet solid, but it's coming this summer, so keep an eye out for that.
That's a fantastic call out. It's a good conference actually. Here's the other mic. If you don't ask it on the mic, then those at home don't benefit. Not that those lazy bastards should benefit anyway, but hopefully everyone's getting their parking pass validated. Right, good, okay. I have no control over that, but I understand that gentleman does. So. All right, very good. All right, so let's talk about Istio. Let's get into this thing. Oh, very good. Yes, sir. Yeah, yep, front down, yep, very good. And it's worth it too. All right. Okay, so here's the deal. Well, there's a few different deals this evening, most of which are good, most of which benefit you. One of those is that, actually, I'll deliver a day-long training, really this, but a longer version, coming up at the O'Reilly's Velocity Conference. They changed the name to Infrastructure and Ops, I think. Anyway, my point of saying that is that there's a lot of material here. We will not get through it all. Actually, intentionally, I will probably cut it short, even if we make it to that point, in part because I'll be tired. Hopefully, you'll have learned enough. You'll feel good enough. So don't stress about it. If you want to run ahead in the labs, you're absolutely welcome to. But the material is self-service, and it's out there already, and it will remain out there for a real long time. And actually, we just keep updating it. It's actually a workshop that's been going on for, well, I guess about 18 months, maybe a couple of years now. So it's just been building and building. We actually created an open source project from this talk, and you'll see it tonight, actually, this workshop. So kind of neat. The reason that the URL is up there and the reason that it's highlighted on this page is because you'll find, I don't know that you will find this talk there just yet, the slides, but ultimately it will be, and all of the rest of the all the rest of the talks that I give, they're there. There's a lot of things that I'm into. Probably the thing that's most pertinent to this evening's discussion is a recent publication of Istio up and running. And thank goodness Zach Butcher also authored this, because that makes it worth reading. But if I can call out Neil for a second. Neil, I owe you. Thank you for bringing up tonight's beer. The pita chips, that was a heavy bag, I know. Thank you, Neil. I appreciate it. And if you like chapter 5, that was my chapter, so it's worth. Okay, good. All right, let's. I think just after this, we're going to open up the keyboards and do this. So we've got a virtual lab assistant this evening, Girish Ranganathan. He is coming to us from Canada. He might even be, well, no doubt laughing at some of the jokes that are going on over the live stream right now. But he is waiting for us in Slack, which ends up being our first thing. In order to make sure that you get your questions answered, if I'm not answering them, or if you can answer them for others, or to the extent that you end up continuing to focus in service mesh land, join this Slack. There's a community of other folks who've taken this workshop in the past. There's a community of people contributing to 3 different open source projects that are under the flag of Layer 5. And you'll find a wide variety of people in there. Some folks that you would know by name that have been up on lots of stages and do lots of interesting work. And some that you'll hopefully meet and make some friends. So join up there. This is the bit that's optional. If you want to subscribe to the newsletter there's occasionally some service mesh related content that comes out. The other thing to do is go ahead and pull up this URL. So it's layer5.io/workshops. And I hope the push that I did earlier, I didn't check. I hope it's up there. It's a list of some of the other workshops that have been given. This one should be listed, and now that I say that, I bet it has the wrong picture. But it has a few different links on it, really resources. I don't know that it has these particular slides just yet. The important thing that it'll ultimately have, I'll highlight this again, but the important thing that it'll ultimately have is a link to the GitHub repo that has all these labs. Okay, how should I ask this? I want to ask about prerequisites and how far everyone got on those. Did everyone, and by the way, there's a short book here. There's actually a copy or 2 of it up here, to the extent that someone teaches me something tonight, maybe we'll do it like that. But there's an ebook version of it there. You got to give up your email address, I think, to Nginx. Okay, everyone's got a laptop this evening. If you don't, look over the shoulder of the person next to you. Who has, do we have everything? Do we have, clearly I'm sure, Mac and Windows in the room? Anybody got Linux going on the desktop? Oh yeah, all right, okay. Respect, yeah. Nice. If you don't have Docker on your local machine, now is the time to use up that Wi-Fi bandwidth. Nothing particularly special to your Docker installation other than one item. If you're using Docker for desktop, and by the way, you don't need to use Docker desktop. As a matter of fact, there's a bunch of different ways to do this evening's workshop, but it's to the extent that you use either Docker desktop or Minikube, it ends up being maybe a little bit easier to follow along. So for those that are on Linux, maybe disregard this particular setup about preparing Docker desktop. So if you're running Docker desktop, if you would go, by default, I think you'll get about 2 gigs of memory allocated to that VM. If you would, we're going to deploy quite a few things into the Kubernetes cluster, the single node cluster that will run in there. So if you bump it up to 4 gigs, we might avoid a snafu. So this is just in preferences, the advanced tab. And then if you don't have Kubernetes enabled, this is the Kubernetes easy button that Docker has provided. So there's the Kubernetes tab in there. Literally, you check the box, and Kubernetes will be downloaded, ultimately installed and running local to your machine. And that would be a single node cluster, and that's fine. I'll be running the same thing on my MacBook here. So I recognize not everyone necessarily may have Kubernetes running at the moment, and I said, hey, we're going to hang out and make sure everybody, we don't leave, no learners left behind. I'm going to move forward because this can happen in the background. So when you'll know that you're ready to advance when you're able to interact with Kubernetes. Anybody first time interacting with Kubernetes tonight? It's going to be fairly painless, I think. Oh, wow. Okay. Well, some of Austin's finest showed up. Okay, that's how it is. Good. So you'll ultimately need access to a Kubernetes system. If you're not using Docker Desktop, or if you're not even using Minikube, as actually that's fine. On Linux, you could just run Docker. You don't necessarily have to run your Kubernetes cluster local to your machine. If you have access to GKS or EKS, or if you just some remote Kubernetes cluster, that's fine. That'll work for this evening. So, okay. So I recognize that there are some of you that came last time and we talked about what a service mesh is and the fact that there are multiple of them and what do they do, and I had promised that tonight we wouldn't really go over, rehash much of that, so we won't. I'm happy to tell you about what a lot of that is. In general, I'll say this very quickly. There's the tool that one of the tools we're going to use is called Meshery. It's an open source tool that this community has been working on, and it's essentially a management plane. When you talk about service meshes, you hear about data planes and control planes. For anyone who has a networking background, it's probably these concepts of data plane, control plane, management plane is probably relatively familiar. If you've ever put hands on physical network gear, that might be you. If not, you might be familiar with control plane and kind of a data plane concept from just from Kubernetes itself. You've got the Kubernetes masters, and then you've got the rest of the worker nodes. And if you think of the worker nodes kind of as your data plane, and then the smarts inside the masters, it's kind of similar. So there's the concept of a management plane. So if you don't have Meshery installed, there's a few different ways to install it based on your OS or just based on what you like to do. This way is showing using Brew. If you don't have Meshery installed just yet, that's fine. Or if you can't use Brew or you need it a different way, that's fine. That we'll have, it's a very quick install. We'll have the instructions later. So, all right. So this is the part where I'm going to skip through some things. I wanted to make sure that we're doing a little bit of conceptual and a little bit of fingers on keyboard. So service meshes, and so I'm going to give you guys the quite abbreviated version of this stuff, and that's that really. To summarize, to put it succinctly, service meshes are probably they create a network, and they create a network that's a services first network, like something of a microservices first network. It's not that service meshes are only good for microservices. It's just that there's more pain in microservices land, and you'll benefit even more from running a service mesh. If you've got the more services you have, sort of the more you benefit from spending time with a service mesh. So. And we're talking all about Kubernetes. We're going to do the lab in context of Kubernetes, but some service meshes that is their world, and they don't expand beyond that world. Other service meshes have a story where they connect to things that are running on bare metal and things that are running on virtual machines elsewhere. Istio is one of those service meshes that will help you connect, that will actually help you sort of modernize some of your older infrastructure, or some of your non-containerized infrastructure. So Istio specifically, big old project. I think I'd said this publicly last time we met. Probably more lines of code than Kubernetes. Ingests a lot of projects. I'm still hoping for someone to prove me wrong on the more lines of code than Kubernetes. I say that with a lot of confidence because unto its own, as a project, there's a fair bit of code that has been written there, but it also ingests Envoy as a project, Jaeger, Prometheus, Grafana, Envoy, and maybe some things that I forgot, so a lot. Now, you don't have to turn on everything. The labs that we go through the workshop, the full workshop does turn on everything on and you touch it, and in the time that we have, we'll probably get Istio deployed, we'll get an application deployed, we'll poke at it some, but we won't flex all of the power of Istio, for sure. I think that if you're like me, visualizations really help in my, in how it is that I learn. Here's every service mesh out there, almost every service mesh out there comes with a sample application, one that just is designed to help show off some of the capabilities of that mesh. And so in this particular case, for Istio, that there's this sample app. It's called Book Info. It's very, the interface is very simple. It's comprised of 4 microservices. Each of those 4 services are written in a different language to help accentuate the power and convenience of a service mesh. And this is a visualization of the traffic flow in a Kubernetes environment. As a user were to request, make a request of this web-based application, and how the front end reaches out and speaks to other, the other dependent services in order to fulfill that response. This will be a lot more clear when we get that application up. This is what that same sample app looks like when it's deployed on Istio, or And in general sense, what it looks like when it's deployed on a number of other types of meshes. Not all of them take this approach, and this approach has to, you've heard folks talk about sidecars. In this case, sidecars are a convenient way of bringing, well, kind of if you think about a motorcycle and having a sidecar hitched onto it, a convenient way of deploying your application or your pod, your workload, and then attaching some utility, generally a utility next to it. It doesn't have to be a utility, but that's kind of the mental state in which this is described. And that could be any number of things. It could be a specialized syslogger or a set of debug tools, or in this case, it's a service proxy. It's Envoy. And this Envoy is the heavy lifter, the heavy hitter of Istio. It's the thing that comprises the data plane. It's where actually all of the traffic that a user would send to Book Info, in this case, send to the application, gets intercepted with each step. It gets intercepted by this service proxy, by this sidecar, by this typo that I have right there. Okay, all right, so moving quickly. Observability, big old reason why people deploy a service mesh. It's a lot of times these metrics are what gets people hooked. Linkerd does a fantastic job of like time to value, like a couple of minutes, and you're seeing some top level metrics on requests coming in and out of your service mesh and in and out of your service. It's pretty neat. Other reasons why is because those service proxies are intercepting all of this network traffic. They're able to open them up and do some layer 7 routing, do some firewalling, do some load balancing, do a number of interesting things. I think more than people have really considered just yet, which is what's got my interest. There's also you can facilitate chaos engineering. You can do some resiliency testing, implement circuit breakers and health checks, and just there's a laundry list of things here. And actually, I skipped over it, but security is certainly one of those. Security inside the GUI center of your microservices, your east-west traffic, if you will. So the sort of the intra-cluster traffic. And providing MTLS, providing authentication and encryption for that traffic in something of a painless way. It's not free. It costs to encrypt. It costs to open up a packet. And that's a point of study, actually, of mine. Okay, so there's a lot more conceptual slides. They're out there for you. Let's skip them. Whose fingers are getting cold? Yeah, yes. So maybe one thing that I think I would be remiss if I didn't say that there's a large part of the value of a service mesh that's provided in helping decouple operators from developers. And there's an animation on this slide that isn't going to work for us, but what's meant by this is that anyone heard of intent-based networking? If you've hung around Cisco for a little while, they've been talking about that for a bit. If you're able to define, infrastructure as code for how it is that you want your systems to behave, particularly for your services to behave and the traffic to behave and the routing to behave. This is really empowering of operators to get a lot more insight, whereas they would normally have to go to developers for some of these things. Service meshes really empower operators. So we won't go over architectures, but rather let's go back to the lab. So let's, if you've got anyone not have their Kubernetes, not have Kubernetes access. Very good. Oh, okay. Nice, good. All right, he got me. Okay, so let's step into, installing Meshery. Meshery is going to help us get up Istio. We're going to describe in the lab how to install Istio manually. You're not missing much when you do it with Meshery. So the first thing we're going to do is bring up Meshery. And this is where the real trick is going to come in this evening. Okay, so I'm on a Mac. I chose to use Brew to install Meshery CTL. To install Meshery, by the way, it's, and I'll give some more context to this project in a bit. It's an upcoming, hopefully, CNCF sandbox project, probably in the next month. Mark the date. If you haven't done this already, this actually should automatically get run when you download Meshery, when you run the script, the steps that are listed there. And Meshery will automatically bring up its user interface, which is web-based. It'll also load up 5 different adapters to different service meshes. The one we're going to use today is Istio. Our hope with Meshery is a number of things, but one of those is to help people facilitate some learning, help people come to understand these different meshes and help them get them up quickly, spin up the environment, spin them down. It's got a long roadmap, but it's starting there. So if you're in an environment where Meshery's been able to conveniently enough grab your user's kube config, that would be in your user folder under the hidden .cube folder, Meshery will just look there for your kube config and load it up. And if it's been successful, and if Meshery, as a containerized app now running on your local machine, if it's able to talk to your Kubernetes, you'd be able to do something like that. Anybody not there? Anybody? I really jumped. Yeah. Okay. Yeah. So that's a great. Docker Compose is the single prerequisite we did not say. So it is. Yes. There, if you grab the Docker Compose binary relatively quickly, you'll be up and on your way. Okay, unless someone says something. Anyone else not there? Okay, nice. Okay, good. The first bit of our lab then is to go ahead and install Istio. You can click on these adapters. These speak to the different service meshes. It doesn't. When you click on them and it says that Meshery is communicating, it doesn't mean that it's communicating with an instance of that service mesh. Rather, it's communicating with a Meshery adapter that speaks to those service meshes. So if we go over to Istio, if you were to go over and install Istio, you'd want to do it with MTLS. Some of the labs are going to go into exploring MTLS and the encryption that's there, the authentication that's there. So we'll get that deployed. We'll let Meshery start to do that. If you're having success, you should start to see a notification in the upper right-hand corner with MTLS, if you would. Oh, were they? Interesting. Okay, very good. Oh, yep. Very good. Inside of Meshry, you'll go over to Istio, and then under Install. The latest Istio with MTLS. And actually, technically, it's been just a little bit since we've updated the lab. And so I think this is pinned to Istio 1.3. We're on Istio 1.4.3, I think, right now. But won't make a difference in our labs, other than the labs have been verified to work with 1.3. And so don't be alarmed if you think you're not running the latest. That's intentional. So if Meshry deployed Istio well, then you should get a successful notification. You should be able to go over and interface with your Kubernetes system. I've just aliased kubectl to K on my system, so there's less typing. If I did something like get pods from all namespaces, it's a bit more than we necessarily need to see. But so I've got a MacBook up here. I'm running Docker Desktop. Some of Docker Desktop and Docker Compose are here. Kubernetes that gets spun up by Docker is here. There's the Kubernetes control plane. And then what has happened now from the command that we sent from Meshry is that Istio has been deployed. When Istio gets deployed, we were talking about the data plane and the control plane for each of these service meshes. Well, what we're looking at here is Istio's control plane. And there are a fair number of components within here. We'll look at some slides to explain some of these components. So at this point, we've got Istio's control plane deployed. Got Kubernetes up, Docker up. Ooh.
Required for Istio to function?
No. Yeah, that's a great question. As a matter of fact, that's such a great question. That's answered in this book here, sir. I don't know if this is all right. Very good. Yeah. So I'll do what I can to regurgitate that. But yeah, and actually that's a recommendation of mine that you would start small. Maybe not deploy all of the Istio components. Meshry does for sake of learning and just being able to touch and interface with all of the components of Istio. But sometimes people just want that very convenient that very convenient encryption between all of their services and the managed certificate authority that comes with a mesh like Istio. Maybe that's why they deploy, and so they only deploy certain components. Maybe they're looking for that observability, and so they only deploy certain components there. So this is the full deal here, but maybe a bit easier and less risky to take kind of piecemeal. You can deploy all the components, and they'll sit there idle up until the point that you tell them to do something. So, good question. Okay, and so what we're doing here is just exploring our environment, making sure that we're up and running. And so, I took a look at the pods. But, you can certainly go over, and most of the Istio control plane, those pods are exposed as services. And we're going to interface with some of these services. I think right now, if you tried to get to any of them, you may not be able to get to any of them. And okay, so one, yeah, the pods may still be very well coming up, but then two, there's a bit of additional configuration that we're going to want to do to get at, to expose some of those services for us to interface with. Okay, yeah, and so this is so there we have lab one. I said, let's take a look at some slides to make sure that we're understanding what Istio is a bit better. In the control plane, the four most prevalent components that make up the brains of Istio, if you will, are these. And these are just their code names, right? That they're project names. There are two, Galley and Pilot, that work fairly well hand in hand. Galley's function is to interface with your underlying platform. In this case, for us, the underlying platform is Kubernetes. And so Galley's responsibility is to interface with the service discovery system of your underlying platform. So in this case, Cube API and kind of etcd behind that. And to then relay, to keep in sync with the underlying platform. And it's Galley's responsibility is not just that. It's also to kind of the point of interaction. As we go to configure Istio later, and we'll say, well, here's an Istio config, here's a set of YAML, let's push it over. Istio, we want you to realize this. We want you to run like this. We're configuring you. Galley has an admission controller that will validate that that's valid config for Istio, so you don't break something. But then it interfaces with Pilot, and Pilot takes that information, that configuration, the cluster environment, and formats it into, in this case, Envoy config. Because Pilot's responsibility is to interface with Envoy, all of the sidecar proxies, to push down that config, or rather, have those sidecars check in and pull down the config. And so that's what's happening here. The two other components of Istio, one is Citadel, and it is the managed certificate authority that I was referring to earlier. So its core responsibility is to generate certificates, roll them, pass those along, help provide identity to each service that comes up on the service mesh. And it's through that identity that you can configure the service mesh to make sure that requests are authenticated in a certain way, or that requests are encrypted, that communication is encrypted between services. Mixer, this last component here, has got a big responsibility. It's called different things at different times. As a matter of fact, it's undergoing a significant re-architecture. Let's come see me after to talk about that, because Mixer's responsibility, sometimes it's referred to as a cache. It does policy checking and telemetry gathering. So it really has essentially two APIs. The checking is things like, hey, user A is making a request of this application. Is that allowed? That check, that policy, that configuration may need to happen in Mixer, and Mixer would help decide whether or not that's okay or not. Or maybe that user has reached a certain rate limit, and so then their request needs to be pushed back. And so Mixer would be responsible for facilitating those decisions. And so as you can imagine, there's a lot of interaction that happens between Mixer and each of the sidecar proxies. And that's in part why it's undergoing a re-architecture to be a bit more efficient with how that happens. There's lots of caching that goes on to already help with that efficiency by which it makes those decisions. But so it does checking. It also does telemetry gathering, which is these reports that are being identified here. So since the sidecar proxy is intercepting all the traffic that's going to your services, it's also able to generate a lot of telemetry, generate logs on who's accessing what service. Things that like if you were to envision kind of an Apache log or an Nginx log, things like that. It's able to generate a lot of metrics about request rates, about a few different things. It's able to generate, help facilitate distributed tracing, which is where the blinders come off for a lot of folks that begin to run a service mesh, and they say, oh wow, so now you're able to see requests from a given client, a given user. You're able to see kind of end-to-end that request. You're able to troubleshoot things like slowness of a request. And if you think about it, troubleshooting a slow request, that's actually a bit more challenging than troubleshooting like a 500 or a 404, because that service is not there, or it's dead, or that endpoint isn't working. But a slow request, that can be really hard to figure out. Something like distributed tracing can really help with that. And so Istio and a few other service meshes really help facilitate that. Okay. Who's got the time? I want to make sure, so we're okay. All right, we're not, okay, all right. We're not doing bad. And it's worth spending just a bit more time on this. And that's to say that we said Envoy is the sidecar of choice in Istio. We said it does a lot of the heavy lifting. It's been the case, and it's been, this is interesting. I haven't gotten to say this before. It used to be the case that it was about Istio .7.8 that Nginx had a project called Engine Mesh that was the Istio control plane, but with the batteries swapped out, if you will, with Envoy displaced with Nginx. So Nginx was the service proxy. It was the sidecar technology. And it was about that time. It was about October of 2018, I think, was the time frame there where they went a different way. In part, the Istio community was so focused on exposing Envoy's capabilities that it wasn't really, in order to move quickly, it probably wasn't spending a ton of time trying to write an abstract interface by which it would interface with any service proxy technology. And so I think it, for a number of different reasons, Engine Mesh got set aside as a project. And so my point is that it used to be that there was a sort of choice of sidecar proxy, and it had actually been quite some time up until, well, I think it's this last October. Citrix announced that they've done that. They've brought in their application delivery controller, their CPX. If you're familiar with NetScalers, and they've got the product line, they've got a containerized version of their load balancer, their service proxy. It's called CPX, and it fits in here. They've got an Istio adapter that inserts CPX instead of having Istio insert Envoy. So kind of neat. They've got a whole story there. I think it's kind of neat because I just figured that would never happen again, and so I was surprised. It's interesting. So I spoke to what each of these control plane components do. Now that we'll go to a slide that describes each one, we'll be able to move more quickly, but I'll say that, so Galley and Pilot, again, they work together. You could think of them as being kind of the head of the ship, if you will. They've got the understanding of the state of the services and where those services are in Kubernetes or in maybe on Cloud Foundry. I hesitate to say Mesos because I just really haven't seen much work being done there. But it does the things that we had said. It provides that service discovery to sidecars. It manages the configuration of sidecars. Sometimes people will, when asked like what a service mesh is, that they might say, well, it's what do they say? I'm trying to. It's configuration management for a bunch of service proxies, and that's an accurate description of one of the functions of what a service mesh does. And that's what Galley and Pilot's roles are. So Mixer, we talked about it doing policy checks and it doing telemetry gathering. Mixer has an adapter interface where you can plug in any number of different adapters or a number of the same type, really to help you interface with your other back-end systems. So if you have a favorite logging platform of choice, then there's generally an adapter that you can plug in that will speak to that platform. The same thing goes for metrics and logs. Same thing goes for checks, like authentication checks. If you're familiar with Open Policy Agent, or OPA, it's one of those adapters that you might plug in and describe policy that you want enforced. And so instead of you describing that policy, that authentication and that security policy in Mixer in whatever DSL it might have, which it doesn't, instead you use an adapter like OPA for that. And so Mixer hands off the check. It's a facilitator of the check. It asks the adapter, it asks that other backend system to make the decision, pass it along, and then Mixer hands off that decision back to the service proxy. Okay, well, boy, I've got this really nasty habit of like trying to describing the thing and then going to the slide that has the visualization. So this is the slide that has that visualization. I think I just hit the wrong. Wow, how many desktops do I have? I think I just closed that. So yeah, this visualization make that so much more clear, right? You've got traffic coming into your application container, the foo container. Before it gets there, and actually as it exits there, the proxy intercepts it, generates a bunch of telemetry about what's going on, ships that off to Mixer that receives it, and then depending upon what adapters you have plugged in, maybe FluentD, maybe Prometheus, Mixer's then able to send that telemetry to them. And to the extent that it's not a telemetry adapter, that it's a OPA or an authentication, a check adapter, then it would make a decision about what to do. Okay, there's Citadel. I probably, I want to make sure we get through more labs, but it's what I'd said it is earlier. Identity. If you ask other people, actually, if you ask my co-author Zach, he'll, to succinctly describe what a service mesh is to him, he'll speak about identity. He'll talk about really the importance of identity and how service meshes provide that. And so that's in large part the responsibility of Citadel here, as it generates certificates for each service that come onto the mesh. They then have their own verifiable identity. Okay, so normally people would get a break about now. That's not us. Who's got questions? Yes, sir. Yeah, that's a great question. So the question was, for those following along at home, is how big is what's the footprint of the service proxy, in this case Envoy? It's one of those very satisfying answers, and it's well, I think there's a couple of ways to answer it. And, one is literally how many megabytes is Envoy itself, the binary. Rather, I don't recollect. Rather small. Negligible might be the wrong. I don't. I'll bet you it's I don't know, less than 100 megs. This a point of consideration, and the thing that a lot of people then, the next question that they ask, and I think the one that's maybe even more concerning, is what's the overhead and how much latency is injected for those packets that get opened up, and what's the price to pay for the value that you're getting out of the mesh. And that value is across those things, is across telemetry and the observability, the security, the fine-grained traffic control. It's interesting, and that's in part why we created Meshery, was to help answer that and do it in a vendor-agnostic way, do it to the extent that we can apples to apples across service meshes, because it's one of those considerations that as you go to choose which one you're going to use, you'd like to know how much you're having to pay for that value. And hence, one of the questions earlier was, hey, do I need to chew off this whole thing, or can I deploy Istio a la carte? And so as you're deploying it a la carte, you can then measure the performance overhead. Envoy is chosen by the Istio team for a couple of different reasons, but one of them is efficiency. So I glossed over the fact that Envoy is written in C++11. Interestingly, the Linkerd version 2, its data plane component is written in Rust. So very efficient. If you guys are familiar with Cilium, that's a BPF-based network filtering capability that's oftentimes used for some of the same service mesh use cases. It's really rather efficient as well because it's using kernel level capabilities. The service proxies, the sidecars that we're talking about, these run in userland. And so, yeah, so they need to be highly reliable, resilient. They need to be able to hot reload, if you will. They need to be able, because you're going to sit there and apply a different configuration to your service mesh, and there's going to be users accessing these services. And so that was one of the strengths of Envoy, was its ability to respawn itself, displace itself, and accept new configuration, sort of handle the graceful reload of its config and a reload of its own binary, or rather of its own process and its own binary. Yeah, good question. And actually, yeah, to the extent that, so I don't know if it's next month or the next month, we're gonna dig into Meshery a bit more, and we'll be able to hopefully have some statistics and some answers about that. So getting back, okay, any other questions? Getting back into, yes, sir. Meshery.io. And so it's a multi-mesh management plane. And so we have it up here. It's helping us do a couple of things this evening. One is deploying Istio. And the other thing it's about to do, I think, in Lab 2 is deploy our sample application, if I recollect my lab. So, yep, so we're going to deploy the sample app. This is the app that I talked about before. In Istio's case, it's book info. So it's made up of 4 microservices. Very simple application, but actually it's a little bit of it's in part the reason that we need to get 4 gigabytes going on in our Docker, in our Kubernetes cluster. There's a Java component in there that's somewhat large. So as we go to deploy book info, there's something that happens automatically. So let me go back and show you a recap what it is that application looks like. I showed you what it looked like when book info is on the mesh, off the mesh, and on the mesh. Here it is off the mesh. There's a Python component. It's the product page, web page. There's some additional details about the books that are in the catalog, written in this service in Ruby. There's a review service where you can star your review of the book, and then there's there's a rating service. And so this is what book info looks off the mesh. This is what it looks like on the mesh. We looked at this earlier. My point of bringing it back up is to say that there's a bit of the magic sprinkles that happen with a service mesh that uses a sidecar proxy model like this, is the auto injection of the service proxy. And so it happens, it's the case that as we go if you go look at the YAML and the Kubernetes manifest of book info, describing that YAML is just the app. It's just these services, these deployments, the application code itself. You won't see a description of the fact that there should be an additional container in each pod. That happens as and when you deploy the application on top of the service mesh. Okay, and so that's what that next slide I was going to show you talks about. Okay, so sidecars are being automatically injected. There is a mutating webhook admission controller that as an application, as new services are being deployed onto your service mesh, this admission controller is ensuring that there's a sidecar injected before those pods are allowed to start up, before book info in this case is allowed to start up. Istio will, through this mutating webhook admission controller, it will inject Envoy. So that's kind of nice because you don't have to go update your manifest to include Envoy. You can also do this manually. There's a utility that comes with the CLI, the command line interface for Istio. It's called IstioCTL. You can use IstioCTL to have it manipulate your manifests very conveniently for you, to inject the sidecar proxy in your manifests. In this case, Istio from, I think, .9 and forward, for quite some time now, it automatically injects these sidecars. And so we're going to see that happen now. These are the commands to these are the commands to confirm that what's going on with Istio, to confirm that you do have a sidecar injector deployed. So if we were to go take this command to look at the Istio control plane and get the deployment that carries the label sidecar injector, in your environment, you should see that you've got one of these present and hopefully running. So let's run it in my system. I do. It's a pod that's got one of one containers. It's been up for a little bit. It's the service that performs the task of injecting in each of these envoys into each service that you deploy on the mesh. You can, and so actually it's worth noting that this is one of those components that sort of, well, it's really nice that you get your sidecar automatically injected. If you take a look, and the way that Istio does that is through a couple of different controls. One of those is the fact that on a per namespace basis, if you deploy a service into a namespace that carries the label Istio injection, then any deployment, any services that you deploy into that namespace, they will be forced to receive a sidecar. They will be brought onto the mesh, so to speak. They will come onto the data plane. And so it should be the case that of the Istio that we installed with Meshery, that our default namespace, and maybe it's not labeled as such just yet. So what we're saying is that the Istio injection label is, well, first of all, disabled on the Istio system control plane, so that Istio isn't automatically injecting service proxies onto its own. It does use Envoy to help with the running of its control plane components, but it doesn't need itself doing it to itself automatically. Does anyone see something different when they run this command? Do they have Istio injection enabled on any of their other namespaces? And it might be just, yes, sir. Oh, you do? Okay, very good. Yep, very good. Then I think then you're sitting pretty, because I think that's one of the things that you can either manually label the namespaces that you want, sidecars injected on, and you would do that. I was saying that there's a CLI called Istio CTL that you can use to do a couple of things. One, do that manual manipulation of your manifests. Something that we don't need to do, because Meshery will run this. I'm sorry, Istio does this automatically for you. Istio, as you've deployed it, has the auto injection of sidecars configured. So you don't need to go over and manipulate YAML. Okay, so let's go into Meshery. Go over to your Istio interface. There's the sample application. There's actually a couple of sample applications in here because, again, Meshery was built initially to be as a learning tool and to do a few other things. But if you were to deploy the book info application here, that communication is going on, that your operation is being submitted, and that it's executing, and you'd get a notification back that really all that's happened here is that Meshery has done a kubectl apply-f. Basically, it's just taken the book info manifests and applied them to your cluster. And so let's go take a look at what that looks like. Pods. As I run this get all pods, I'm seeing that the book info has been, as an application, has been deployed to the default namespace. And it's those 4 services that we talked about: the details service, the product service, ratings, and reviews. And you'll notice that there's actually 3 versions of the reviews service: V1, V2, and V3. And that had to do with your ability to assign stars as a user, stars to a book as a user of this sample app. We'll look at that. And the reason that they're in there like that is, one, service meshes are, like we'd said, like they're able to do a lot of granular traffic control and manipulation. To that extent, they can be used for canarying things, or for A/B testing, or for rejecting traffic, or for cataloging traffic, or for, a lot of things. Or, as we might get to in the labs, if you're signed in as a particular user, maybe you've got a particular cookie present, or maybe you're using JWTs, or what is it, JWT? What do we say? JWTs? Thank you. Yes. Yeah. As we use JWTs, no. That Istio, or Envoy and Istio combined, can open those up, take a look, and then route traffic or deny traffic or whatever based on values inside there. So So hopefully we'll get to that lab. Okay, so we've got our book info deployed. Let's go let's just do a kind of a refresh. Mine is still, the pods are still initializing. Some of them are running. Now, here's kind of the interesting thing to note is that the details application, it's just a single pod, a single container pod. I think it was Ruby that this details app is written in. But it actually has 2 containers in this pod. Who can tell me what the second container is? Yes, sir. Sidecar? It is. It's the sidecar. It's Envoy. So I said we had some swag. So feel free to openly reject this swag. I'll only take it extraordinarily personally. You, sir. You like Prometheus? Oh, yeah. All right. Well, I hope that's what this is. Nice. All right. Okay, very good. Clear, filtered, purified water. You'll live longer. All of the good, awesome. Yeah, that's right. If I can, I think we should take it. We should probably go in there, take a look at and explore around. Maybe poke at Envoy, take a look at its configuration, just confirm that in fact Envoy is in there. I'm going to set the microphone down. Let's see if we can do that. We're just describing our product page, and this will be fairly verbose. This is no one raised their hand in here when I said, "Is anyone fresh to Kubernetes?" So no doubt the kubectl describe is a familiar command. If we were to go to the top of this output, what we're going to be able to do is come to understand a bit of a surprise actually. So we come over to our stanza that talks about containers. So we come down. We've got containers here. We've got one container that's called product page. So that's the sample application component, and it's running on port 9080. It is. It's got some configuration. It's. If we keep going, we'll find that I skipped Envoy. And it just uses the name Istio proxy in Istio land. If we take a look at the image, I think even there you don't see Envoy listed. If we go ahead and exec into this thing, we can take a look at Envoy's config. And you're seeing some of that config here in terms of how it's supposed to work. So that's not necessarily surprising because that's what we just said, that there was a sidecar that's auto-injected. What might not be known to all of us, or readily apparent, is that there is such a thing as an init container, and this is the intention of init containers are that they live and die rather quickly. That help me out here. If you're familiar with like cloud init, if you've had to provision VMs and just before the VM is provisioned, maybe you've got a script that you want to run as that VM is taking life. That's kind of the same concept around init containers. Maybe you've got a particular pre-provisioning thing that you want to do. In this case, the pre-provisioning thing that Istio wants to do is to manipulate the IP tables of the pod. Recall from your Kubernetes days of learning that containers and pods, there's lots of many Linux resources are namespaced, and some of those namespaces, some of those resources are shared amongst the containers in a pod. And actually, the networking namespace is shared between any of the containers that are in the same pod. They're all in the same networking namespace. As such, when Istio auto injects Envoy, it also injects this init container and has it run for a split second. I think we can take a look at how long it was when it started, when it stopped. Oftentimes, kind of in the same second. Start time. Anyway, it eludes me, but it does it rather quickly. It manipulates the IP tables of that network namespace such that it then controls where traffic goes. It makes all inbound traffic requests that are coming into the application. I'm going to go back to that visual. It makes it such that network traffic doesn't, even though it's addressed, in this case, maybe to the product page, it doesn't go to the product page. It gets, Envoy takes a hold of it, Istio takes a hold of it and redirects it. And even within the pod, even if the product container didn't need to call its downstream services, if it was going to try to respond directly back to the client, to the requester, well, it'll, unbeknownst to product page, to that code, Envoy, again, is going to force the interception of that traffic, and it'll come back through Envoy, and then Envoy will send it out. This sidecar proxy will send it out. And actually, there's no code change in your app. That just happens based on IP tables being configured, and they're configured by that init container that runs for a split second as you're deploying onto the mesh. Okay, good. So maybe we won't exec into Envoy, into that container and poke around. Unless someone's really interested, we could. It might be in the lab. Wow. Okay. All right. So some of you, you might have gotten bored with some of that explanation and tried to go access your book info, your sample app, because it is deployed, it's sitting there running. Hopefully all the pods are up. Hopefully mine are up. Hopefully you didn't run out of memory. I've had a couple of times students have run out of memory wondering why their mouse isn't responding to anything. In order to access book info, we need to go ahead and tell Istio to allow to a couple of things. Allow inbound traffic requests that are headed toward this sample app to in fact grab that, match that traffic, and when you do, route it over to this sample app. And that's done using a couple of constructs. And these are Istio-specific constructs. The first one's an ingress gateway. And the second one is a virtual service. So let's go and so I don't know if I've got other, yeah, great. Yeah. Here's the best visualization apparently I have for the fact that on the edge of your mesh, for Istio anyway, there's an ingress gateway by which all inbound traffic that comes into the service mesh flows through this ingress gateway, and that's a point of control. And it's a point of configuration, so we need to configure that gateway to tell it, hey, when traffic is coming to the sample app, intercept it, match it, route it over to the sample app. It may be the case that, so let's go take a look, because it may be the case that Meshry has taken care of part of this for us. Let's see. Okay, so Istio deploys a lot of CRDs. Some of this design is going away. At the moment, and at least in this environment, these are the CRDs. The two that I was saying that we're interested in is one of them is a gateway, and a CRD is a custom resource definition. It's a way of describing new constructs, new objects that are domain specific. In this case, Istio specific. So if you didn't deploy Istio, you wouldn't get a response back. You wouldn't have these different types of Istio resources. So one of them is a gateway. The other one is a virtual service. If we went and, did a get gateways. There, the gateway was deployed for us by Meshry when it deployed the sample app, and again, that's just as simple as taking the manifest and applying it. So let's look at what that manifest contained. It's fairly short. So the YAML that gets applied is really rather short. What it's saying is just saying, hey, for any host, any source traffic that's coming in, this is really describing like what traffic to match, and any inbound traffic that's sourced from anywhere but it's destined to using HTTP, and it's using port 80. That traffic matches this gateway. Now, what to do with it is kind of the next thing, and that's where virtual services come into play. So if we get virtual services, there was one deployed along with our sample app. Let's take a look at its configuration. It'll be probably a little bit longer. But if you're used to running, configuring, in my mind, it depends, I think, on what your background is, what type of operator you are, what type of developer you are, what type of net admin you are. That I think different analogies maybe work for different people, but if you're used to configuring maybe virtual, I forget, it's been so many years. If you're used to configuring Apache or Nginx and you're describing different services, virtual servers that you're load balancing to, virtual hosts, very good. That's Apache, yes, or? All right, very good. Who's got me on Nginx? Oh, don't. Now, I did say Austin's finest earlier. Yes, sir.
Did you have an Nginx question?
Yeah, you recollect the Nginx term for virtual hosts, basically, the equivalent? Server name. Very good. Okay, very good. So anyway, so my mind kind of goes to that type of a concept for Istio virtual services. Yeah. Oh, hey. Well, yeah. Well, you almost got. It was like almost got gypped. Now we've got some different things. Who all here? And actually, maybe specifically, have you had one of these before?
Oh, what is it?
Because this is a Kubernetes. Oh God, what do you call those things? What do those kids have? It's a Kubernetes spinner. Actually, let me do this. Fidget spinner. Yeah. Try it. Not a fan. Okay, yeah. So this is actually, it doubles as a throwing star. It's really heavy. Actually, just feel it, because this thing is you have to have
This is really good.
I think you have to have a license to carry in this building with that.
Probably.
Now, all right. So very good. There is your choice of container D, linker D, or fluent D. They all end in D.
What are any of these?
Please, yeah. Any of these would be take your pick. Yeah, that's yeah. Damn. Okay. Nice. Thanks. Yeah. Very good. Nice. All right. There's anybody else has cold feet? There's more where that came from. Okay. Okay. Good. All right. So we've got the kind of conceptual understanding of a gateway of a virtual service. If you've done CLI on a router or a switch, that some of this is conceptually aligns there as well. We just matched our traffic. We said traffic source from anywhere that's addressed to, that's using HTTP, TCP, addressed to port 80. That's interesting to us. We're gonna have a gateway that's open to receive that, and that conceptual gateway, that logical gateway that we configured, the book info gateway, it actually applies. The config that gets applied to Istio's ingress gateway. That singular ingress gateway that's on the edge of Istio, its config gets applied there. And then that second component, the virtual service, says, well, hey, more at a path-based level. So great, if traffic that's inbound there, if it's service name indicator, if it's SNI, or if it's HTTP path matches these things, and in different ways, then go ahead and redirect to our product page service, the sample app that we're running, and that's got this port exposed, 9080. Now, let's go. I don't recall from memory at this point. Let's go run a Kubernetes get services. This should pull back the services that are running for our in our default namespace, which are the book info in my environment. If we do that for the Istio control plane, we'll get, again, that long list of control plane components. One of those, and the one that we've been talking about here, is the Istio ingress gateway. This is an instance of Envoy. This is a pod, a service that's running Envoy. The configuration that we just applied affects this ingress gateway. This ingress gateway then has a number of ports that are exposed. The one that was of concern to us, the gateway that we just configured, was for port 80. And the configuration that's been applied is now mapping the external port 80 to the internal in-cluster port 3180. That's going to be important to us. Sorry, I said that I said that inversely. Anyway, this port will be important to us as we go to access our sample app in a moment. So we're essentially ready to access our sample app. And before we get into telemetry, let's pull up that app. There were some other things to explain here. So. Okay, I don't think I've got the instructions in the slide deck. So better that we go here. I think we're on, it was about lab 2. We deployed our sample app. Get this bigger. So we looked at the fact that there are labels, and the injection of sidecars happens based on labels on namespaces. We didn't necessarily go back to verify that the default namespace that we ultimately provisioned book info into received that label, but clearly it did because because we saw envoys injected, and so anyway, just double verification that in fact that namespace, the default namespace, now has the Istio injection label with a value of enabled. Okay, we did our book info deployment. We want to go over now, and now that we've deployed book info, we configured our ingress gateway, we configured our virtual service, and really on your system, you should only have one gateway configured and one virtual service configured. So if you were running these commands at the same time that I was, that you should just see the same ones that I saw. There's a way, this longer command here that would go and essentially retrieve the port that I was just talking about. So that port 31380, that's the port that the Istio ingress gateway here has mapped to port 80. And so this other command I'm using templating just grabs that and pulls it back conveniently. So 31380 is often where you will find your book info app deployed. What you want to do now is, how many folks are running Kubernetes? I'm sorry, Minikube. A number of us. Okay, very good. By chance so what we're going to do now is look for our Kubernetes cluster IP address. And I think in my system, based on running Docker Desktop, I don't necessarily, this particular command, the way it's formatted, doesn't conveniently return back the IP address of my cluster. In later versions of Docker Desktop, if memory serves, you should be able to find the Kubernetes IP address, the cluster IP, at kubernetes.docker.internal. If not, localhost might be our trick. If you're running Minikube, if you do I think it's a Minikube IP, it'll tell you the IP address of where your Kubernetes cluster is. You'll take that IP address, and you'll append this port 3183/product page, and you should see book info come up. So let's try it. Service matches the /product page. Okay. Anybody having the book info come up for them? Yes, sir, you are. And Minikube is your?
I'm using Docker.
Just straight.
Docker Dexter.
You are? Okay.
Yeah.
On a,
48.
oh, see, that's where I'm probably confusing myself. Hold on. /product page. And so you did kubernetes.docker.internal.
I did both of those.
Okay, see.
Those 480/product page.
I'm switching to a remote Kubernetes cluster. I think it's a 2-node environment. We'll see. I'll see if as a matter of fact, I might have the wrong kube config for it, but it'll be hard for me to walk you through if it's not. Let me switch over to that environment. Okay, nice. All right, so I'm connected to this remote cluster. It's a 2-node environment. I think it's Ubuntu. I think it was brought up with kubeadm. To the extent that stuff matters, it's 1.6.2. Shouldn't matter. Let's see what it's got running. When I reload my kubeconfig there, Mesher will give me a choice of, it'll read the kubeconfig and then say, what cluster did you want to connect to? Well, it's the other cluster, which I'm hoping that it can connect to. Okay, yeah, it is. These are errant messages. Okay, good. I forget where we were. We were going to test out, right, so I don't think that this environment necessarily has Istio. We'll go deploy it real quick. We'll do it with MTLS on. Hopefully that'll be successful. It'll start up Istio. That book info that's already running in that environment is probably running on top of Linkerd. Yeah, I'm guessing. Let me just remove Linkerd. Hopefully that kills Linkerd. Let me also maybe clean up the environment. Can I get this? By the way, the nice thing about Meshry is that you can take sample apps from different service meshes and deploy those different sample apps across the meshes, so you can kind of test them out, if you feel what's going on. There's a different functionality, different performance across them. It also clearly lets you interact with your own services. Okay. So let's see what all is happening now. Yeah. Get to their book info product page. Okay. Wow. There's only 2 of us in the room, and one of them just happens to be me. Okay. Okay. Anybody got AirPlay by chance? Anyone want to share their desktop? Because if you have AirPlay, we can share your desktop up here, which is really going to put people on the spot. What? Oh, you do? Oh, that's great. Oh, no. I was, sorry. I didn't even see your hand raised. I was just trying to make a joke. Yeah, if you do, actually. You can do, all right, so did we, I don't know if that's probably a swaggable offense. Interested in any socks by chance? Okay. Oh, okay, well, yeah, well, oh, nah, okay, yeah, no, anyway, so good. So now that we've got product page up, if you take it and reload it a couple of times, you're gonna probably see the default behavior of the stars changing colors. What do we expect is happening there? If you recollect how the product page is designed. Yeah, that's right. It kind of, by default, the config is set up to load balance across the same versions. Sir, which one did you, or this guy? Nice. Yeah, all right, very good. Good. It's Service Mesh. Yeah, so. Great, okay. So we've got book info up. We reload. You guys have the behavior that you were describing. Great. All right. It's time for us to begin to look at some of those other, well, let's start off with observability and look at some of the capabilities that the Service Mesh provides us around observability. We're 7:43, so time check. Prometheus, Grafana, Kiali, Jaeger. These are the four projects that, four of them that are observability related that come inside of the control plane. Prometheus and Grafana are helping us deal with metrics that are generated every time that we hit refresh. We get some of those that telemetry generated. These control plane components are not exposed external to the mesh by default. So the next set of steps that we would go through is to update their configuration and expose them. Hopefully to do that relatively quickly. So going back, so I'm back on my Docker, I'm back on my local machine. So what you would do is, I'll switch back my environments, but hopefully you're seeing inside the labs, it tells you to go and edit the service description to change the service from cluster IP to node port. So let me go to the slides to make this more. Okay, so we are going to dig into observability. Mixer deals with observability, and I'm not sharing on the. Thank you. Mixer deals with observability. You can plug in a number of different adapters, like I was saying before. Here's a list of some of those. It's not exhaustive. There's a fair number of them. But usually logs, metrics, traces. It also deals with checks. I talked about those checks in terms of like access control, authentication and things, but it can also be like policy and rate limits. And it's just checking. Mixer would facilitate the checking to make sure that a request is allowed in that case. So if we start by looking at metrics, we're going to want to go over and edit the Prometheus service that's running in your Istio control plane. When you edit it, there's a couple of different ways to get your Prometheus port exposed. One way is to change that from cluster IP to, or I think it's load balancer to node port. I'm trying to remember. So in my system, I'm going to disconnect from that other cluster. I need to switch contexts. Docker makes that easy. easy for a single-handed person to do. Back to Docker Desktop for me. Great. If we go edit the Prometheus service running in the Kubernetes or in the Istio control plane, instead of having to type cluster IP, we'll do node port. That soft escape key is just a beautiful thing. Anybody got the new Mac with the actual physical escape button back on it? Everybody else is equally suffering. Yes, all right, good. Oh yeah, oh. Right. Anyone smart enough not to get one of these systems in the first place? Okay, great. Okay, so we've edited the service. What we could go do is go look at that Istio ingress again, the one that is exposing all of our services external to the cluster. So we could do a get on our Istio system namespace for its services. In this case, the one that we're concerned with is the ingress gateway. And where it is, we're concerned with Prometheus, and where it is that Prometheus is exposed. So if we grab this port here, for me it's 3707. And now that I've learned the hard way that it's local host, for me, local host 37707. Should get at our Prometheus instance that's now exposed. We can begin to pull back. There's a number of different statistics that you can see, and some of those would hopefully pop out at you as being metrics about Istio control plane components. So we talked about Citadel being the managed certificate authority. You can see some statistics about whether it was. I don't know that we're going to see any. No. Anyway, bad statistic, but just an example that, like, hey, not only are you going to see information about the traffic that's flowing across your services, but also information about how Istio itself is performing and the control plane components. Okay, that maybe only get so exciting up until the point that we start to use Grafana and we start to use Meshery to generate a bunch of load instead of sitting there clicking refresh. I think it's after we generate a bunch of load, we'll get some exciting things going. Okay. Look at that. Okay, so you basically go do the same exercise for each of those observability or those monitoring / observability related control plane components. So you go over and change Grafana over from cluster IP to node port so that we could then access it. And based on time, I'm not sure if we should step through, but basically the next set of exercises do just that, and they just walk you through connecting up to, as a user, connecting up to those capabilities. I don't know that I mentioned Kiali quite as much, but it provides a couple of things, the most notable of which is a visual topology for your Istio specifically, for your Istio configuration in that environment and how it is you've got Istio configured, what gateways you've got configured, and virtual services. It'll show you some of the traffic as it's going across as well. The reason I was skipping over was to say that what becomes interesting is to generate some telemetry against. Let's go ahead and maybe expose Grafana. In the time that we have, maybe we can expose Grafana, connect up Meshery to Prometheus and Grafana, generate a bunch of load, see if we can see some interesting stats on our cluster. And then we'll call it quits. Yeah, good question. So, so the question is, hey, what's the traffic flow that's happening here? Are we having, as a user, as an administrator of this system, are we having to access Grafana and Prometheus, Prometheus and Grafana through the Istio Ingress Gateway? I'm going to see if I can prove it out by showing you the config here. In terms of whether or not those same ports are exposed on the Istio Ingress. And so the last one I dealt with was, I think it was, it ended in 330. I don't know if it was 3, but essentially the answer is going to be that no, hey, we're not going to see the same ports exposed here. So yeah, that you're able to expose these directly, in part because we're dealing with, yeah, I guess it wouldn't necessarily be obvious, but we were just editing the Kubernetes services and dealing with, sort of with Kubernetes independently of Istio controlling some things. And so that's in part true because what we had said before when we looked at the labels, the Istio and auto injection labels, if I can pull it back up, and what we were seeing was that Istio injection had a value of disabled for the Istio system namespace, essentially the Istio control plane that Grafana and Prometheus are running in. So they don't necessarily have, they're not on the mesh, so to speak, and so hence that we don't necessarily have to expose them through the Istio ingress. Okay, so we've got Grafana and Prometheus up. We've got our product page up. We want to take a look at some statistics. Let's go do a couple of things quick. The deployment of Grafana that comes with Istio is comes with a default set of dashboards that you would find in Grafana. I'm here, and so I don't know. Let's take a look at the Mixer dashboard. Yeah, I fumbled around there for a second. If you go to, I think it's under the plus sign. If you were to go, no, it's not folder, not import. Home man. I think I ended up going to manage. No, shit. I spend very little time inside of dashboards. Home. Yes, that is actually. Yeah. Thank you. And then I ended up, well, that wasn't quite it. Yeah, anyway, there's the Istio folder, and we picked it from there. Actually, so we would see that same representation inside of Meshry if we were to connect up Grafana. So let's do that quick. When you connect up Meshry to Grafana, it will go and read all of your dashboards and let you choose which ones you'd like to suck in or import in here and have them represented here. It's not that you necessarily need another interface for viewing graphs as much as you need another interface for viewing graphs. It makes it very convenient, particularly when you want to go answer the question that was asked earlier about performance and the overhead of the mesh itself and the various components, is that you'd be able to do something like generate a bunch of load against your sample app, or really any endpoint. I think you can go ahead and generate load against google.com, and you should get some insights here. Cloud Native Austin. You don't right now. You don't necessarily have to tell it the specific mesh. There's configurations that you can give. There's different types of load generators that you could use to run the tests. Honestly, at this point, I think I've between the switching of the environments, the VPN, and things, I may have hosted my system. Anybody else running that and seeing the graphic where you're generating load? It's doing statistical analysis on the load that is generated, and it measures latency and throughput. We'll in another meetup we'll talk more about Meshry and how it's able to do that. The importance of doing that right now for this workshop is that as you go through and digest all of what you get out of the Prometheus deployment, the Grafana deployment, the Jaeger deployment, the Kiali deployment, is that it's a lot easier to comprehend and see that value when you've generated the load there, like I was going to do through Meshry. With that, given that it's 8 and there's a hard limit, we have a couple of minutes left. Hopefully no one's disappointed that we didn't get through all of Istio. I kind of said that point much earlier. Hopefully what you have is links to all of this that you can self-service on later. You've got a Slack that you're connected to go ask questions in. There's a lot of other learners in there. And there's also a bunch of seasoned pros in there. There's the folks that wrote CPX and the Istio adapter for Citrix CPX. They're in there. They're maintainers of Meshry. There's some VMware maintainers. There's some Cisco distinguished engineers that are in that channel. They've written adapters to Meshry. So for network service mesh, I think that's actually a topic of discussion next time. Anyway, my point is it's a varied channel. And so if you're asking a question in there and learning, then so is everyone else. Yes, sir.
Yeah, so I missed half of this, but does Istio have a solution or whatever? I think you mentioned it for like an ingress controller or routing?
Yep, it does. Yeah. It's, so the question was, does Istio have, an ingress controller? Or does it have, how much traffic manipulation capability does it have? And as a matter of fact, I was hosting a CNCF webinar earlier today on. It was given by Traffic, the continuous folks. Okay. Oh, very good. And one of the questions on there was pretty similar. It was actually in this case. So I'm sorry. The answer to your question is yes, absolutely it does. Very in depth. As a matter of fact, that's why people are attracted to a service mesh or like Istio in the first place, because yeah, it does very granular layer 7. It lets you, some of the labs in here let you go look for text inside of a cookie, manipulate the traffic based on what values you find in there or in your JWTs, JWTs, JOTs. God damn it. All right. Sorry, so the person that asked the question earlier may be of interest. Their question was, does an ingress controller, does it provide any ability to manage egress traffic? And essentially the answer with respect to Kubernetes and ingress controllers is no. That said, you could use Kubernetes network policy, maybe Calico or others, to help you manipulate some of that egress traffic, or a service mesh. And not all of them have an egress controller. Istio is one of those that does. It's an optional component to our point earlier, that Istio's got a lot of capabilities and a number of components, and you're free to not deploy them all, or even to the extent that you do, not enable them all, not configure them all. So.
I guess I have 2 more questions. So the next thing is, does it work well or does it work well with Cert Manager?
Yeah, that's another great question. There's a managed certificate authority inside of Istio. So you're hitting it on the head, and its code name is Citadel.
My last one is, I'm assuming there's no reason why one of them plays well with Helm.
The Istio does, or as an installer.
Before deploying applications, I can still use it.
Yeah, for deploying applications onto the mesh, that you could still use Helm. Yes. Yeah. Yep. Correct. That's a little bit of the magic sprinkles that I think some people internalize that as there's a little bit of magic happening here, and for some that makes it's a little bit uncomfortable. 'Cause it's like, well, hey, I just did the thing that I normally do. And it so happens that the namespace that I deployed into carries this label. Based on this label, for Istio, it says Istio injection label, and if it's enabled, then there's a mutating webhook that I always get it's such a weird mutating admission webhook controller, or that enforces the fact that any services that are deployed into, whether they were deployed with Helm or Tiller or other, that are deployed into that namespace, before they're admitted into the namespace, before they're realized and scheduled, that they get a service proxy sidecar injected into each of those application pods. Or I shouldn't say injected into each of the pods adjacent to your application container. It's a good question. So anyway, we I think one could do another one of these that's maybe more smooth, but then two could clearly do the second half of the workshop. Or if there's interest in things, find me somehow or message any which way you like, really. But I would encourage you to influence the next few topics that are forthcoming. If you go look, there have been a number that have been posted, most of which are technical. Many of them are mesh-oriented or clearly cloud native. There's one that's coming up. It's on establishing an open source program office, which actually is arguably more painful than the technology that we talked about tonight, and depending upon which lawyers you engage with. So. Do we have one more question? I thought we saw. Yes, sir. Yeah, no, that's a great, awesome question. It was that Envoy is injected at the pod level, such that if you had 7 application containers inside of one pod, and then you put in this 8th container, Envoy, or this service proxy, that through that init container that runs for a split second to manipulate the IP tables, and since they're all sharing the same network namespace, that same IP tables config that basically says, hey, we're going to just funnel, we're going to use localhost in that network namespace. We'll use localhost to anytime that any of those application containers are addressing some host externally, they'll just do what they normally do. They'll address the host, just like, but then as soon as those packets leave the application container, go out and get managed by IP tables and by Linux networking, they get funneled through Envoy.
Short question, I guess. How would you say that it's representative of what Istio does functionally if you were to say that it kind of namespaces in the sense that it allows you to put a layer over the namespaces where there's cross-pod communication, like it kind of enables granular control of that?
Yeah, it's it's another good question and kind of an intriguing thought. I'll repeat it just for posterity, and that is, hey, would it be entirely inappropriate to consider that one of the value propositions of a system like Istio is to help you overlay namespaces on top of your namespaces, or to help you segregate existing namespaces you might already have set up? I don't think that that's inappropriate as of late. It used to be a few releases earlier that some of the way in which Istio, some of the constructs in Istio and the way that the system was designed was that there were some harder boundaries. So some examples being things like within a of multi-tenancy, of like running Istio on a cluster. I'm a tenant of the cluster, so are you. You want to be on the mesh, I don't. How do we segregate that? In part, like some controls came out around the labels. How do we if we've got how we run multiple control planes, Istio control planes in the same cluster, or how do we run multiple clusters but under management of the same control plane, kind of multi-cluster things. How do we expand the mesh over to these VMs and these bare metal systems that are running? And so there is a bit of slicing that can happen. Some of this is manifested by way of trying to improve performance of the service mesh. So if you imagine in large scale environments, you've got 1,000 nodes in your cluster or multiple clusters. If you've got a single control plane, and we talked about Galley and Pilot in the past, and them needing to be the head of the ship and sort of maintaining the state of like where all the services are and how they're getting shuffled around, how they're getting rescheduled, and so that they can have this, so they can do the configuration management of each of the envoys that are adjacent to all those. Like you can imagine, actually we're sort of reincarnating a bunch of how networking and routing tables and routing protocols kind of work, but in a different layer. That there are scale limits, and there are like, hey, not every envoy, to your point, necessarily needs to know the state of the full network, like of all these other namespaces. If you think about like a subnet, this isn't like we're a little bit tongue in cheek here, but yeah, there's some interesting. This is, I think you're hitting on a couple of things that I was alluding to before about, I think some things that folks have yet to, or not many folks have yet to really explore just yet. There's a ton of power in grabbing the packets and opening them up. There's a lot more than you can do than just security, observability, and traffic control. Some other things. One of the biggest value propositions of a mesh is that as a developer, as someone focused on writing business logic and providing value around what the application does specific to your environment, is like letting a lot of the infrastructure concerns melt off. Like, hey, don't write in the fact that, don't hard code in the rate limit for this service. It might make sense in one environment, but not in the next. You don't want to have to go back and ask the developer to make a code change and have to do a rollout of a new version of your code just to move the rate limit from one thing to the next. Okay, fine. Well, maybe you're using a client library, GoKit or Hystrix or some other library that implements that fairly well, but is actually language specific. Well, it's pretty annoying. You might be running one version of GoKit and someone else is running a different. You're going to have a non-uniform control. Maybe you've got Java going, I've got Ruby, we're in the same environment. Like, anyway, this uniformity of observability and uniformity of control and the ease by which you can apply that config through YAML or through, in an infrastructure as code way, really empowering to the operators and also to the developers to say, hey, let's manage the state change here in an SCM and Git and have that roll out. I'm not sure where I was going with your question, but it was just like, hey, yeah, there's, yeah. I'm excited about it. All right, very good. So I've got this way of droning on and things, but thanks for hanging out. Thanks for coming. With same time in 5 weeks from now, I think every third Thursday or what have you. So.